Okay, so I've messed the microphone up again on day 2, but we're trying this again. So hopefully this one will work. But this should take care of NTI day 10 and 11. We're still on section 5.1. So this first part will be your homework for NTI 10. Okay, and then I'll tell you when we're getting ready to do the NTI 11 part. Okay, so we are looking at simplifying trig expressions now. Okay. And in our first example, we are asked to simplify sine x times cosine squared x minus sine x. So basically, we're going to be looking for ways to factor or use the trig identities that we talked about yesterday. But we have this big trig expression, and we're trying to simplify it down to maybe even just one term and even just one trig expression. Okay. So when we look at what we're given, the first thing that I'm noticing is that when you look at the first term and the second term, they both have a sine x in common. Okay. So we are going to factor out that GCF of sine x. So think of this as like if you have 4x minus 16, you would take out the GCF of 4. Okay. Well, same idea here, but it's just this time our GCF is a trig function. So factoring out that sine x, we're left with cosine squared x and then minus 1. Okay. So sine x was our GCF, we factored it out, and now we have something that looks like the distributive property. Okay, when I look at what's left in parentheses there, that cosine squared x minus 1, okay, that looks familiar. It kind of looks like one of our Pythagorean identities that we talked about in the first set of notes. So, do you remember the identity sine squared x plus cosine squared x equals 1? Okay. Well, one other version of that was solving for sine squared x. So when we solve for sine squared x, we end up with 1 minus cosine squared x. So that's really close to what we have in parentheses there, but it's flipped, it's backwards, okay? So anytime your signs are opposite, then you should be able to just multiply that whole equation by negative. So negative sine squared x would equal negative 1 plus cosine squared x. Okay. So that negative 1 plus cosine squared x is the same thing as cosine squared x minus 1. So now I can rewrite my sine x, and then I can take that part in parentheses and change it to negative sine squared x, because that's what it simplifies down to based on that Pythagorean identity. Okay, and now when you multiply and you have the same base, then you add the exponents. So if you had an x and an x squared, that would give you an x cubed. In this case, we have a sine and a sine squared, but our sine squared is negative. So that's going to multiply out to give me negative sine to the third x. Okay. So that big expression that we started out with, sine x cosine squared x minus sine x, that simplifies down to negative sine to the third x. Okay, next example. We're still simplifying. But this time we want to simplify sine theta plus cotangent theta cosine theta. So this one looks a lot like that last example. However, as I look at it a little closer, I don't have a GCF like I did on the previous example. Sine theta and cotangent theta, cosine theta, they don't have anything in common. So when you don't see a way that you can factor out a GCF, then think about your trig identities. Okay, cotangent, I can relate that to sine and cosine because I have an identity about that. Okay, I know that cotangent, when I look at my quotient identities, cotangent can be rewritten as cosine over sine. So I'm going to substitute that in for cotangent, cosine theta over sine theta. Okay, because that's a quotient identity. And now, okay, I've used that quotient substitution. Okay, when I look at that right term, I should be able to take cosine theta over sine theta times cosine theta, and I should be able to multiply that together. So sine theta plus cosine squared theta over sine theta. So I multiplied the cosines together because that cosine that stands alone is like cosine over 1. So cosine times cosine is cosine squared, and then sine times 1 is just sine theta. Okay. Now, what do you have to do when you are adding fractions? Okay, anytime you add fractions, you need to have a common denominator. Okay. So I'm now going to rewrite this expression with a common denominator. And my common denominator is going to be sine theta. Okay. So my first term, sine theta, is going to have to be multiplied by sine theta so that I have my new denominator. So sine squared theta. And then the second term, I already have my denominator, so I can just write cosine squared theta. And then when I look at the numerator, sine squared theta plus cosine squared theta should look familiar. Isn't that one of our Pythagorean identities? Okay, so that part is equal to 1. And that leaves me with 1 over sine theta, which is a reciprocal identity. 1 over sine theta is cosecant theta. Okay, so take a second to look over that, make sure it looks okay. Okay, and then we have one more example over simplifying. On this last one, we want to simplify. And this time we're given sine theta over 1 plus cosine theta plus cosine theta over sine theta. Okay, while this does not really look anything like the last example, we're going to end up kind of proceeding like we did in one of the steps of the last example because we're adding fractions. And what did we say we need to do when we add fractions? Okay, get that common denominator again. So this time our denominator is going to be 1 plus cosine theta times sine theta. So when I look at that first term, that first fraction, what's missing in that denominator that I have in my new one? I'm missing a sine theta. So if I multiply the bottom by sine theta, I have to do the same thing to the numerator in the top. Okay, so sine theta times sine theta is sine squared theta. And then on that second fraction, I'm missing a 1 plus cosine theta in my denominator. So I multiply top and bottom by 1 plus cosine theta. So second fraction, I'm going to distribute that cosine, and I have cosine theta plus cosine squared theta. Now that numerator looks a little messy, but we're just adding, and so when you add, you can rearrange terms. So if I look at my first term, cosine squared theta, and I look at my last term, my first term, sine squared theta, and I look at my last term, cosine squared theta, what is sine squared theta plus cosine squared theta? Did y'all hear my puppy barking? I've never heard her bark this loud. Of course, while I'm teaching. But I had to come outside because I thought it would be quieter than inside. And I ended up having to bring her with me because I had her in my laundry room and she started tearing up the wall. Yeah. So I'm trying to think of where to put her next. So I just brought her outside with me for now. Anyway, so like we were saying, sine squared theta plus cosine squared theta, that's equal to 1. And 1 plus cosine theta is what we're left with in the top. That looks good because what am I seeing in the bottom? See that 1 plus cosine theta? Okay, that's going to give me something in common to cancel. Okay, so now my 1 plus cosine thetas cancel out, and I'm left with a sine, but that sine is in the denominator, so it's 1 over sine theta, and 1 over sine theta is cosecant. That's a reciprocal identity. Okay, now I know these are challenging. Okay, they are challenging on days where we have actual school and class, much less from afar. Okay, but I thought that this would be easier than trying to learn to graph by yourself. So I'm hoping that maybe we'll be back together whenever in time to be able to do that graphing section by itself. Okay, but that's the end of NTI Day 10, page 377. We're going to do 25 through 36 all, and basically that part is matching. So I'm kind of easing you into it because whatever you end up with, you should see that as one of your choices. So hopefully that'll help steer you in the right direction. This is going to take some patience. Okay, feel free to send me questions, but really reach out to each other. I mean, we would spend a lot of time in class pairing up and working on these things together. So I hate that we're missing out on that, but we can still do it from afar. Okay, so reach out to each other and do your homework over FaceTime or over the phone together. Text each other if you have questions. That will really help a whole lot. Also, if you get frustrated, skip one, go to another one, because sometimes a lot of times in math it gets harder as you go along, but these are kind of scattered all over the place. So you might think, the very last one is the easiest one there was. It just depends on how you look at things. So try to have some patience, and then when you get frustrated with one, stop and move on to another one, or take a break if you need to. Okay. All right, so moving on to NTI 11, where this assignment is still going to be simplifying, but there's also some factoring problems in there. So we're going to focus more on the factoring aspect for this part. Okay. So on our first example, it's going to ask us to factor each expression. And while we did some GCF factoring on NTI 10 notes, this is going to be more of like sum and difference and trinomial factoring and that kind of thing. So factor each, and on A we have secant squared theta minus 1. And for B we have 4 tangent squared theta plus tangent theta minus 3. Now, think of these in terms of algebraic expressions first. So when you look at A, if you have secant squared theta minus 1, doesn't that look like x squared minus 1? Okay, and we can factor x squared minus 1 into x plus 1 and x minus 1. So same idea here, except we will write secant theta plus 1 and secant theta minus 1. All right, then for our trinomial, 4 tangent squared theta plus tangent theta minus 3. Okay, that looks like 4x squared plus x minus 3. So if we're factoring that trinomial, we're going to have a 4x and an x, and then factors of negative 3. We're going to have negative 3 and plus 1. So that gives us our x in the middle that we need. Okay. Now for this problem, we don't have x, we have tangent instead. So we're going to write this as 4 tangent theta minus 3 and tangent theta plus 1. Okay, and this one will be our last example for NTI 11. Okay, on this one, we're going to factor cosecant squared x minus cotangent x minus 3. Now, that looks like a trinomial, but do you see how it's different from part B? On example B, we had everything in terms of tangent, but this time we're mixing up cosecant and cotangent. So we can't just immediately factor it like we normally would a trinomial. So what we're going to do instead is look, we have an identity that relates cosecant to cotangent. Okay, we know that cosecant squared, okay, that's equal to 1 plus cotangent squared. That's one of our Pythagorean identities. So see why this is important that you get those memorized as soon as possible? Okay, that way you'll have a better idea of what to plug in for stuff. Okay, so when I substitute that in, now I have an expression all in terms of cotangent. I have some like terms, 1 and negative 3, that I can combine. So that's going to give me cotangent squared x minus cotangent x, and then minus 2. Now take a second to see if you can factor that. So if you need to pause this for a minute and then compare answers with me, okay, but that would just be a good way for you to try something here and see if you can factor that trinomial. Okay, you're going to write it as x squared minus x minus 2, so that factors into x minus 2 and x plus 1. So that will be cotangent x minus 2 and cotangent x plus 1. Okay, so for this assignment, you're going to be doing some more simplifying, but then you will also see some factoring in there as well. So this is NTI 11, page 377 again. We're going to do 37 to 79 odd, so you should be able to check some answers in the back on those. Okay, please send me your questions, and like I said before, text each other.